In today's video, we will be using a comparison test to check whether a given series is convergent or divergent. So before coming to that, first we have to know what is this comparison test, okay? Suppose two positive series are given, let's say summation un and summation vn. Then summation un will converge if summation vn converges, and this one will diverge if summation vn diverges. That is the comparison test. So using that one, let us check whether these given series are convergent or divergent. Let us do the first one. Our un from here is what is un? Our un is twice n minus 1 upon n into n plus 1 into n plus 2. Now we need to know Vn, and we can find Vn from un itself, okay? So now this one, if n is very large, then un, this one, will be nearly the same as 2n by n into n into n, that is 2n n cubed, which is nothing but 2 upon n square. This one is for large values of n, okay? So from this un we can find Vn, or Vn is 1 upon n square. Now next, divide un by Vn. What is un? Our un is, it is twice n minus 1 upon n into n plus 1 into n plus 2. Now we divide by Vn, that means we divide by 1 upon n square, so n square comes to the numerator, n square, okay? So from here we have twice n minus 1 into n square upon n into n plus 1 into n plus 2. So now take the limit n tends to infinity un upon Vn. That is equal to twice n minus 1 n square upon n into n plus 1 into n plus 2. So from here, if we take common by n, so we have n into 2 minus 1 upon n, and then we have n square. From here also we take common n, so we have n, and from here also the same n, so we are left with 1 plus 1 upon n, 1 plus 2 upon n, okay? Here we have n cubed, here also n cubed, so they get cancelled, okay? So now limit n tends to infinity 2 minus 1 upon n by 1 plus 1 upon n into 1 plus 2 upon n. Replace n by infinity. So 1 by infinity is 0, 1 by infinity is 0, 2 by infinity is 0. So from here, in the numerator we have only 2, and in the denominator we have what? 1 into 1, that is 1 itself, which is equal to 2, and 2 is not equal to 0, so 2 is finite. Okay, so that is done. So now, according to the comparison test, we know that UN will converge if Vn converges. Okay, so check Vn. What is Vn? It is this one, right? So Vn is 1 upon n square. Summation Vn, summation 1 upon n square. This one is of the form summation 1 n to the power of p, which is a p series. And we know that for a p series, the p series will converge if p is greater than 1. So comparing this one with this, we get p to be 2, and 2 is greater than 1, so this series converges. So we see that summation Vn equal to summation 1 upon n square converges, being a p series with p equal to 2, which is greater than 1. Okay, so that's why, hence, by comparison test, summation un, which is summation twice n minus 1, n plus 1, n plus 2 converges. So this is the comparison test. Now using the same one, let's do the second, the third, and so on. From the second, what is un? Okay. Our un is 1 upon root over n into n plus 1. And this one, for large values of n, it is nearly the same as 1 upon root n into n, and that is equal to 1 upon n. Okay, so we can find Vn from un. What is Vn? It is 1 upon n. So now next, divide un by Vn. So that is equal to, what is un? It is 1 upon root over n into n plus 1 divided by what? By Vn, that is by 1 upon n. So that n comes to the numerator. We have n in this way. So we have n upon root over n plus 1. Now take the limit n tends to infinity un by Vn. Limit n tends to infinity. What is un? Un by Vn, it is n upon root over n into n plus 1. Okay, so limit n tends to infinity. So from the denominator, let us take common by n. So we have n into 1 plus 1 upon n. Limit n tends to infinity, n. Now this one is n square, and then if we take it out with the square root, it is only n. So inside the square root we have 1 plus 1 upon n. So n tends to infinity, replace n by infinity. 1 by infinity is 0, 1 plus 0 is 0, and the square root of 1 is 1 itself. So the answer is 1, which is not equal to 0, and this one is finite. Okay, now un will converge if Vn converge, otherwise it will diverge. So look at the series Vn. What is Vn? It is 1 upon n. this series diverges. Okay, since it diverges, then by the comparison test, summation un also diverges. So let us do the third one. What is our un? It is 1 upon, okay, 1 upon square root n plus 1 plus square root n plus 2, and for large values of n, this one is nearly the same as 1 upon root n plus root n, so which is equal to 1 upon 2 root n. So find Vn from un. What is Vn? It is 1 upon root n. Okay, now divide un by Vn, or un is 1 upon square root n plus 1 plus square root n plus 2. Divide by this one, so it is square root of n, which is equal to square root n upon n plus 1 plus square root n plus 2. Okay, now take the limit n tends to infinity, un by Vn. Root n plus 1 plus root n plus 2. Okay, next take this one to the denominator. So we have root n plus 1 by root n plus root n plus 2 by root n. Limit n tends to infinity. So here, for this one, we can write it as n plus 1 by n. It means the same thing because of the square root, n plus 2 by n. So this one is 1 upon, here we will get 1 plus 1 upon n, and here 1 plus 2 upon n. Now n tends to infinity, replace n by infinity, so we have 1 upon infinity is 0, 2 upon infinity is 0, and then square root of 1 is 1, square root of 1 is 1, so 1 plus 1 is 2. The answer is half, which is not equal to 0, and this one is finite. Okay, then take Vn. What is Vn? Summation is 1 upon root n. This one also, it's the P series. What is P here? Or P here is half, which is less than 1, right? And we know that for the P series, if P is less than 1, then the series diverges. So this series diverges, this one diverges because P is less than 1. So since summation Vn diverges, we conclude that summation un, which is summation 1 upon root n plus 1 plus root n plus 2, diverges. Hence we are done with number 3. So let's do number 4. What is our Vn? Our Vn from there is 1 upon n plus 2 into 2n plus 5. Okay, now here also this one is nearly the same as 1 upon n into 2n, which is equal to 1 upon 2n square. Find Vn from un. What is Vn? It is 1 upon n square, and then divide un by Vn. Our Un is 1 upon n plus 2 into twice n plus 5. So we have n square. And after that, take the limit. N tends to infinity, Un by Vn. So we have n square by n plus 2, 2n plus 5. Limit n tends to infinity, n square. From here take common n, and then here also n. We are left with 1 plus 2 upon n, and here 2 plus 5 upon n. Okay, so they get cancelled. Now when you replace n by infinity, you will get here 0, here also 0. So 1 into 2 we have to have. This one is not equal to 0. Okay, and also it is finite. So now take summation Vn. Where is our Vn? It is summation 1 upon n squared. This one also is a p series. P here is 2, which is greater than 1. So this series converges, being a p series with p equal to 2, which is greater than 1. So that's why our summation Un also converges by the comparison test. Okay, let's do this one, the fifth one. What is our Un from there? It is square root n plus 1 minus square root n minus 1 upon n. So we have to find Vn from this one. So let us rationalize the numerator. Rationalizing the numerator, we have n plus 1 plus n minus 1. N plus 1 plus n minus 1. Okay, so from here we will get n plus 1 minus n minus 1. This one is of the form a minus b, okay, into a plus b, which is equal to a square minus b square. Hence we have n plus 1 minus n minus 1 divided by n into root over n plus 1 plus root over n minus 1. From here we have minus n plus 1. We have 2 by n root n plus 1 plus root n minus 1. Okay, so from here we can find our Vn. Our Vn is, first, this one is nearly the same as 2 upon n root n plus root n for large values of n, and this one is equal to 2 upon 2 n root n. So from here our Vn, what is our Vn? From there our Vn is 1 upon n root n. This one is nothing but n to the power 3 by 2. Okay, so now divide Un by Vn. Un is 2 upon n root n plus 1 plus root n minus 1. Divide by this. So we have like this. From here, okay, first take common by n. So we have 1 plus 1 upon n plus, here also the same thing, n 1 minus 1 upon n. Okay. So now 2n to the power 3 by 2 n. Now this one is taken out and we are left with root over 1 plus 1 upon n. Here also root n, root over 1 minus 1 upon n. So these two are taken common, and n would with this one minus 1 upon n. Okay, this is nothing but n to the power 3 by 2, so hence they get cancelled. We are left with 2 root over 1 plus 1 upon n plus root over 1 minus 1 upon n. Okay, now if you take the limit of this one un by vn, take the limit n tends to infinity, what you will get, 1 by infinity is 0, 1 by infinity is 0. So here you will get square root of 1 plus square root of 1, and that is 2. So 2 cancel with 2, we get 1, and this one is not equal to 0, this one is finite. Okay, so now take summation vn, or vn is 1 upon n to the power 3 by 2. This one also is a p series with p equal to 3 by 2, which is greater than 1. So if p is greater than 1, we know that the p series converges. This one converges. So since this one converges by the comparison test, summation un, which is summation root n plus 1 minus root n minus 1 by n, also converges. Okay, so let's do the last one. This one, our un is n cubed plus 1 minus root n cubed. We have to find vn from this one. So first we have to rationalize this numerator. So we have minus n cubed into root n cubed plus 1 plus n cubed. We are rationalizing the numerator. Root n cubed plus 1 plus root n cubed. Okay, so here it is of the form a minus b into a plus b, that is equal to a square minus b square. So that is, we have n cubed plus 1 minus n cubed, root n cubed plus 1 plus root n cubed. From here we are left with 1, and then we have, let's take common by n cubed. Here we don't need to take common because we need vn, and this one is nearly the same as what, 2. Okay, n cubed plus n cubed, which is 2 root n cubed. Okay, so from there our vn is 1 upon root n cubed, and that is equal to 1 upon n to the power 3 by 2. Okay, now divide un by vn. Our un is which one? It is 1 upon root n cubed plus 1 plus root n cubed. Divide by vn, divide by this. So we have n to the power 3 by 2. N to the power 3 by 2. So from here, let's take common by n cube. So we have 1 plus 1 by n cube plus root n cube. Okay, n to the power 3 by 2 by, take this one out, we have root n cube root 1 plus 1 by n cube plus n cube. And now we can take common n cube together, root n cube into 1 plus 1 by n cube plus 1. So these two get cancelled because root n cube is n to the power 3 by 2. And when we apply the limit n tends to infinity un by vn, we apply the limit here, n tends to infinity. That means 1 by infinity cube is 0. So square root of 1 is 1 and 1 plus 1 is 2. You will get the answer half, which is not equal to 0, and this one is finite. So now take summation Vn. What is summation Vn? It is summation 1 by n to the power 3 by 2, which is a p series with p equal to 3 by 2, which is greater than 1. And we know that when p is greater than 1, then the p series converges. So this series converges. Since this one converges, we conclude that summation un also converges by the comparison test. Okay, that is this one also converges. So this is all about the comparison test for checking whether the given series is convergent or divergent.